So when it comes to solving rational equations, my guaranteed tried and true method is 2 steps. Make common denominators and then solve the numerator equation. Now there's one little caveat. Step 0 would be to identify points of discontinuity. So we have to be concerned about points of discontinuity because they will possibly lead to extraneous solutions. And an extraneous solution is a solution that comes out algebraically, but then it doesn't actually work in the denominator. Because we could have, say in this case right here, say I get an answer of 3 at the end. Well, 3 doesn't work because I can't divide by 3 or divide by 0. And plugging in a 3 would make a division of 0 scenario. So I cannot, from the outset on this problem, my step 0 would be to say I can't have an answer of 3. So if I get 3 at the end, that's called an extraneous extra answer that I can't utilize. So here we go. Working through my 2 steps, just keeping in mind step 0. The job is to make common denominators. That's the key right here. If you can make common denominators, you've got this. So first thing you want to recognize about this is that -5 is actually a rational expression with just a 1 denominator. The other 2 have x minus 3's. So the only part that's missing is this -5 needs to get a x minus 3 denominator. So to make that happen, I multiply it by the number 1, specifically the x minus 3 over x minus 3, 1. And so now my denominators are all the same. As soon as all the denominators are the same, you can completely ignore them outside of the fact that, we noted that x can't be 3. We can completely cross that out and mentally avoid that completely and just rewrite the numerator equation, because that's step 2. You just solve that. So we just bring this numerator equation down as if it was the problem in the first place. It's -5 times x minus 3 plus 3 equals 4x. And now we bring the problem back down to the rigor of Algebra 1 or Math 2. So now we just distribute and get -5x plus 15 plus 3 equals 4x. As soon as we isolate x, we've got a victory. So we take our 15 plus our 3 to get 18. So -5x plus 18 equals 4x. And then we need to make terms be on the same side, like terms. So I'm going to add the 5x to the right. Going to move the 4 and the 18 around if you'd like. But 18 equals 9x. And then we finish by dividing both sides by 9. And we have an answer of 2. X equals 2. So since that's not -3 or not +3, we're good. This answer is our solution. All right, a very similar problem. This time it's a little bit twisty because we've got a negative sign here. So don't let that absorb with your eyes into the equal sign. It is a negative sign. First thing you want to do is bring that up to be in the numerator. Make it a plus with a -4x on the top. And now the same thing over here with this -6. I'm going to realize that -6 is actually -6 over 1. And then I look around at denominators. I have an x plus 1, an x plus 1, and then the number 1. Well, that number 1 needs to turn into an x plus 1. So I multiply the top and the bottom of that middle fraction by x plus 1. Notice I kind of made this little space for myself on this problem between the 6 and the equal sign to cram in that x plus 1. And now as soon as my denominators are all the same, I completely ignore them, except for the fact that step 0 is that x can't be -1. Just a side note, I can't plug in -1 right there. So if I get an answer of -1, that's a problem. So keep that in our mind as we finish up. The finishing up looks like taking this top equation off to the side and solving it. So I'm going to bring that down below. I got 4 minus 6 times x plus 1 equals -4x. So as soon as you have the numerator expression solvable, you work through it. -6x plus a -6, so -6. Bring my 4 down, equals -4x. Put like terms on the same side and move all the numbers to the other side. So I'm going to add my 6x over here. And that's going to give me a 2x on the right. I'm going to combine my -6 and 4 to get -2 equals 2x. I should be able to divide both sides by 2, and I should have a result of x equals -1. Oh, wait, -1, I said at the beginning, x can't be that. Oh, that's a problem. Exactly. So what that means is, if that's my only algebraic solution, there is no solution. This problem has no soul. You got an answer of -1, and -1 is point of discontinuity, which means the only possible solution is a false solution. So there is no solution. All right, this problem, very similar in difficulty. We've got x plus 7, and then an x out in front instead of a constant like the last ones. So make this x be over 1, and then we'll recognize it needs to have this x plus 7. Now, before I get too excited and moving, make this minus sign go up. So it's really a -7 with a plus sign between fractions. And then the first fraction needs to have the number 1 multiplied be x plus 7, x plus 7. And hear me say that is the number 1 because anything divided by itself is really 1. So I'm just multiplying by a 1. Now, after I multiplied by that 1, all the denominators are common. So I can just set my numerators as an equation off to the side. So this is just x, I'm going to put it in front here, times x plus 7 minus 7 equals x. So all I did was rewrite the numerator as a standalone equation, and then you go through the business of solving it. Now keep in mind, if we get an answer of x equals -7, that would be wrong. So if we get an answer of -7, we will have to throw it away. So we get x squared plus 7x minus 7 equals x. Ooh, this time we get a quadratic, so we're going to have to work our x method. So we're going to set it equal to 0 and then factor to solve. So we subtract both sides by x, and we get x squared plus 6x minus 7 equals 0. So we run to the magic x and put a -7 on top and a 6 on the bottom, and our magic numbers are going to be 7 and -1. So we factor this, which is going to give us x plus 7 and x minus 1 equal to 0. And when you have it factored in factored form, you're supposed to set each factor equal to 0 and solve each one separately. So we get to subtract 7, and we get x equals -7. And over here we add 1, and we get x equals 1. Well, we said earlier x can't be -7. So that solution, it happened algebraically, but it is an invalid solution, and that happened because we multiplied by the number 1 over here. So that's an invalidated solution. It's extraneous. The only real answer to this rational equation is x equals 1. In this next example, we are going to have to factor to recognize our least common denominator by seeing that there's a product over here on the right-hand side by factoring out a greatest common factor of x times x plus 1. And what that does, it helps me see that this x plus 1 is missing one part. It has the x plus 1. This one has also an x. So to get the least common denominator of everything, we have to take and make sure everything has its own little piece. So this one has the x plus 1. This one has x plus 1, but it needs an x. So I need to multiply the top and bottom of the first fraction by x. Now it has both products in common. So now it's a common denominator. But we've got this 3 that's in the middle. It only has 1 in its denominator, so it needs both products, the x and the x plus 1. So I write it there because it needs it, but I can't just multiply the bottom. I have to also multiply the numerator, x times x plus 1, so that I'm really multiplying by the fraction 1. Anything divided by itself is 1. As soon as I have every denominator common, they all have the common denominator of x times x plus 1, I can take that numerator equation off to the side and solve it. So now I take this numerator, which is off to the side. This is x times x, so x squared. And then this is plus 3. And then this x times x plus 1 is all there. So I'll put 3x and then x plus 1. And then the equal sign is there in the middle. It kind of got lost. I wrote over it. Equals 1. So then I work it out. I distribute my 3x, and that's going to give me 3x squared plus 3x. And then bring down your equals 1, bring down your x squared that was in front of that. Continue to combine like terms so that we can get to solving. So we get 4x squared plus 3x, and then it's equal to 1. But we want to make it equal to 0 so that we can potentially factor and solve. Worst case scenario, we'd have to do quadratic formula. So subtract 1 on both sides, and we get 4x squared plus 3x minus 1 equals 0. Now this time, we have an a value of 4, so make sure we multiply the 4 and the negative 1 to get negative 4. The denominator is, or the bottom of the x is 3. So our magic numbers are going to be positive 4, negative 1. Do not write those as your factors, though. These are the magic numbers so that we can turn this 3 into a 2-term piece so that we can factor by grouping. So we make that 3x turn into 4x minus x, because that's still 3x. Bring down our negative 1 and bring down our 4x squared. And we factor by grouping. So it's still equal to 0. And we group the first 2 and the second 2 separately. So there's a 4x in common of these two. And if I divide this by 4x, I get x plus 1. And then the second 2 terms have a negative 1 in common. And if they didn't, I'd have to force it, because I need this to be a negative 1 times x plus 1. Still equal to 0. And now we have a common factor, binomial factor of x plus 1. So I factor that out, and that's going to be x plus 1 times 4x minus 1. And that's still equal to 0. So running out of room on the bottom, I'm going to bring it up over here. So I've got x plus 1 times 4x minus 1 equal to 0. Now, solving will get my x plus 1 equal to 0 and 4x minus 1 equal to 0, which will give me an answer of x equals negative 1, which I'm going to have to watch out for and look up above in a moment. I'm going to throw that answer away in a second. So x equals 1/4 is my other answer and the only actual answer. So be careful to make sure that you look at this negative 1 and check it up here and see if it works. And it doesn't work. As soon as I see this factor, by the way, as the same as the factor of one of the denominators, I know it's not going to work, because I can't have the denominator 0. So that definitely is not going to be a possibility. So this answer you throw away, it's extraneous, but the x equals 1/4 will work, because it doesn't get thrown away. A 0 would have been a problem, and a positive or negative 1 is an issue, but 1/4 is not a problem. That is my one solution for this rational equation. All right, this time we see that we have a x plus 5, an x minus 5, and then an x squared minus 25. So hopefully we're familiar enough with the difference of squares to recognize that x squared minus 25 is actually x plus 5 times x minus 5. So basically, this right fraction has one of each of the products, and each of these ones on the left-hand side of the equal sign are missing one of the products. So we've got to work through and multiply each of these factors, these fractions on the left, by their missing part of the denominator. So this x plus 5 needs an x minus 5 multiplied to the top and bottom to multiply that by the 1 that makes the denominators common. And then the x minus 5 needs a x plus 5 multiplied to the top and the bottom, so that it now has the common denominator with both products. As soon as everything has the same amount of products, the same denominator, a common denominator, you disregard the denominator, except noting, of course, that if I get an answer of 5, that's a problem. If I get an answer of negative 5, that's a problem. So x can't be those two things in the end. So if I get one of those, we'll throw that away. But moving forward, we're just going to take our numerator equation down below and solve it. So we have x minus 5 times 1, so it's just x minus 5, plus this x So I'm going to distribute that to save a step. So x squared, so plus x squared plus 5x, and then my equal sign, and then we've got 2x plus 7. So then I combine like terms, which are on both sides of the equal sign. I'm actually going to move these to the left-hand side, subtract 2x and subtract 7. So I'm going to subtract 2x right here and subtract the 7 over here so that I've got 0 on the right side equals, this is 3x's now, plus x squared, which I'll move around in a moment, and then minus 12. And then I have an x over here still. So now it's equal to 0, and I just should combine like terms and rearrange it. Put the x over here with the 3x to be 4x's. So it's going to be x squared plus 4x, and then I'm going to drag the negative 12 to be in the constant position so that I can factor that. So now it's equal to 0, and now I need to do a magic x, and this time I don't have to do the grouping. Negative 12 in the top, and then a 4 in the bottom of my x. So then I multiply a 6 and a 2. Should give me, with a minus 2, should give me the right, 6 minus 2 is 4, and 6 times negative 2 is negative 12. Now that's jumping right into my factored form because I don't have an a value of anything other than 1. So it's okay. So we get x plus 6 and x minus 2. So bring those over here. I'm going to say x plus 6 equals 0 and x minus 2 equals 0, which will produce an x equals negative 6 and an x equals positive 2. And neither one of those were issues because it was just 5 and negative 5 that would have been a problem. So I have 2 solutions to this rational equation. All right, so this time we don't have any factoring to do. What we have to recognize, though, is that this has a plus 2, this has a minus 2, this one has a minus 2. Well, I can't just make that plus a minus. I kind of wish I could, but if I multiplied by negative, this x would change also. So really, we have to see this is a one factor, and this x minus 2 is another factor of a difference of squares, x plus 2, x minus 2. So you actually have to go through and multiply each one by what it doesn't have, so they have common products. So this x minus 2 needs the x plus 2. So I multiply top and bottom by x plus 2 on this fraction. And now it has x plus and x minus 2. This middle one, same thing. I need an x plus 2 multiplied against it. Put some parentheses around that x plus 5. And this first fraction, if I put an x minus 2 as a product in front of it, now all of them have the same products, the least common denominator. They have one of each binomial product. And now since they are all the same, I can just solve my numerator equation. My numerator equation takes all this off to the side and works it through. So saving one step, I'm going to try to distribute each of these so that way there's a little less work down below. So 7 will go into the first ones to be 7x minus 14. And then this x plus 5 times x plus 2 will be FOILed to be x, so plus x squared plus 2x. And then we have plus 5x and then plus 10. Equal sign coming down, and then we're going to distribute that 7 to be 7x plus 14. So now our goal is to get everything on one side of the equation, factor, solve, and combine like terms. So I'm going to subtract this 7x, which is conveniently going to cancel that 1 out that was over here. So those are going to be 0. These are 0. I'm going to subtract 14, which doesn't conveniently cancel out this 14. They actually combine, so don't make that a 0. But now the right-hand side is equal to 0. And then we've got negative 28 here. And then we've got plus x squared. Combine our 2 and 5 to make 7x's. And then bring down our 10. So the only thing I have to do is bring my negative 28 to the back. So we've got x squared plus 7x. And then the 28 coming to the back is going to give me a negative 18. equals 0. So now we magic x with negative 18 and 7. Hopefully quickly you see 9 and negative 2. And because there's an a value of 1, we don't have to suffer through grouping. We just jump to our magic factors. X plus 9 and x minus 2 are the factors. So you set each one equal to 0, but I can tell you right now that we're going to have an issue because you can see that this x minus 2 was one of my denominator factors right here. So this is going to cause an extraneous solution of 2 when I get there. If any of your factors show up in a denominator, you know it's going to produce an extraneous solution. So anyway, x plus 9, set that equal to 0, and I get x equals negative 9. And then right here, the x plus 2, you set that equal to 0, you get x equals negative 2. But as I referenced, you're going to throw that one away. It's extraneous. The x plus 9, or x equals negative 9, is the only valid solution to this rational equation. All right, in this rational equation, what we're going to see is that these first two fractions have one binomial multiple of what this trinomial is going to factor to have. If I factor this, I put a 56 on the top and a negative 15 on the bottom, we'll pretty quickly recognize a negative 7 and a negative 8 are my magic numbers, through which this factors to produce x minus 7 and x minus 8. The key is knowing that it has two products that make the whole denominator. Well, each one of these has one of them, so if I just multiply by the other one, I will have common denominators. So this second fraction just needs that extra piece it doesn't have, the x minus 8. This first fraction just needs the piece it doesn't have, which is the x minus 7. So you look for the missing product and then fill it in by multiplication, top and bottom, by the number 1, and whichever product divided by itself is 1. Makes that work for you. And then now once my denominators all have the same products, they are common denominators. I don't have to write it in this trinomial form, just factor form works great. Since the products are all common, I can just take those numerators as one big equation off to the side and solve it, or down below specifically. So I'm going to distribute my x to give myself a little space to save a step. Distribute that x in there, give me x squared minus 7x. And then I'm going to add my plus 5 times this binomial. So plus 5 times x, and then 5 times negative 8. It's going to be negative 40. Equals x. So our job, as before, is to set it equal to 0, and then factor by subtraction of x here. And bring everything down. So equals 0 now. Minus 40 comes down. I'm just going to combine these x's here. So it's really negative 7, minus 1 is negative 8, plus the 5 is negative 3 x's, and then bring your x squared down. So then we factor using our magic x technique, negative 40 on top, negative 3 on the bottom, and we should have 8 and 5 with a negative on the 8 to make it work. So then we have our factors as x minus 8, x plus the 5 equal to 0. And just as before, I recognize this x minus 8 is going to cause an issue because it's a factor that's already on the bottom. So when I get x minus 8 equal to 0 to produce an x equals 8, that solution is extraneous. And then over here, x plus 5, set that equal to 0, and get x equals negative 5 when I solve. That is my valid solution, whereas the 8 caused a point of discontinuity. Negative 5 is the solution for my rational equation. All right, in this problem, we're back to seeing a constant out in front. In fact, it's the number 1. The number 1 could be any fraction, so that's going to be great. But we'll take a second look here in a minute. We've got x squared minus 4, so I'm going to factor that to see that this x minus 2 is going to be one of the products from difference of squares here. So x squared minus 4 turns into x plus 2, x minus 2. So there's two products I need. This middle fraction has just one of them. So I need the top and the bottom of this fraction to get an x plus 2. That 1 can be anything divided by itself. Well, what it needs to be is this denominator divided by itself. So this 1 needs to turn into x plus 2 times x minus 2 top and bottom. And now all my denominators are common, so the story has gone. You just set the numerators equal to each other, or not equal to, as the numerator equation, and then you bring it down and solve it. So this x plus 2x minus 2, we already know its product. It was right here, x squared minus 4. So I'm just going to not have to FOIL that. I'm just going to bring it down as x squared minus 4. And then I have plus 5 that needs to distribute to the x plus 2. So it's going to be plus 5x plus 5 times 2 is 10 equals 2. And then set it equal to 0, factor, and solve. So subtract 2 from both sides. Now it's equal to 0. I'm going to bring down my x squared. I have negative 4 with 10 and negative 2, so it's really 10 minus 6. So it's going to bring down a 4 and bring down your 5x. So combining my like terms, I'm going to now factor using the magic X technique. So I'm going to put a 4 on the top and a 5 on the bottom. The only way to get a product to go bigger when you add it is to be the number and 1. So 4 plus 1 is 5. 4 times 1 is 4. So because this has an a value of 1, I get to use the magic factoring without the grouping. So that's going to be x plus 4 and x plus 1. Neither one of those factors are one of my denominators, so both of them are going to produce valid solutions. I'm going to get x plus 4 equal to 0. Subtract the 4 over, and you get x equals negative 4. And then x plus 1, you set that equal to 0. Subtract the 1 over and get x equals negative 1. So two solutions this time, a negative 4 and a negative 1.